Hi guys, this is James with JS Studios Games, and today we'll be adding on to the 2D Terraria-like sandbox games by creating caves using cellular automata. So without further ado, let's boot up Unity and get started. We'll be using the same game from the terrain generation video. We'll just be using another scene. So wait for Unity to load. And we'll create a new scene and we'll call it cave generator. Our cave generation, and we'll create a cave generator game object and a cave generator script. Open that up in Visual Studio. So we don't need the update function, we'll take that out. Everything's happening at the beginning. Remove the comments, and we want a public int for the length, for the width and the height. So let's get both of those. And we also want a 2D array for the points of the cave, because cellular automata works by having a bunch of random points and then making them like their number. So we're gonna have a range that'll be a public int, and it'll be the random fill percent. Oops, forgot a space there. Alright, and last but not least, we need a awake function, because we're gonna call the generate function and the awake function. So we're gonna make our generate function, we'll call it generate cave. Call that in the awake function, and we want to set a new cave point, reset them all, and then we also want to create a seed. That'll be the randomness, and we'll make it a random dot range between 0 and I don't know, one with a lot of zeros. Make it a big number. Now we want a system random, so system dot random, and we'll call this the random choice. This will be whether it's whether you put a block there, it's empty, and it'll be a new system dot random of the seed dot get hash code. So now we want to loop through all the tiles in a for loop. So for x is less, so we're gonna loop through it for the width, and then y is gonna be for the height. And then we're gonna say if random choice dot next, so it's just gonna keep on going to different random choices, and we're gonna say that if it is less than our random fill percent, then it will be the cave will be at that point we'll have it be a 1, and then else it'll be a 0. So that's just saying whether or not we're gonna put a block there or not. If it's a 1, we're gonna put a block, and if not, then no block. Clean it up a little bit. And then we're also gonna create another function, a place grid function, and we want to loop through all the tiles again to fill them in or instantiate the blocks, so we need to loop through all of them. And we're going to say that if the cave point is 1, then we'll instantiate it, and if not, then we'll do nothing. So here we want to get that stone, so we'll have a public game object, and there we'll just get our stone game object. Put that in here, instantiate the stone at the position, and with a rotation of quaternion.identity. So I want to call the place grid in the start after we've already generated the cave. Give us a width, the height, the random fill percent, and put it in our stone prefab. And as you can see, there's a randomly generated grid, but it looks nothing like a cave right now, but that's how cellular automata works. You can see it's different here, but you just generate a lot of random points, and then you make them like their neighbor. That way it makes shapes. You can see whenever we turn up the random fill percent, it's much more clogged up. So I'll put here if x is equal to 0. So here we're just seeing if it's on the rim. We're gonna make it a wall because we want the outside to be surrounded. So we're just checking if it's at any of the outside points, and if it is, then we're gonna set it to 1. And we'll make this an else if, just for cleaning up and make it run right. Alright, now that we have that, let Unity load, and whenever we run the game, we should see that there is a wall around the edge. So now we want to smooth it, and we want to go through multiple smooth iterations. So we'll have a variable to control that, and we'll say for each of the smooth cycles, we're going to go through and smooth it again until it looks right. So in the smooth cycle, we want to loop through all the tiles again, so we'll copy paste that loop function. And here we're going to have an int where we want to see how many neighbors are walls around it, and if it's greater than a certain threshold, then we're going to make it a wall, and if it's under that threshold, then we're going to make it not a wall. So here we're going to go x minus point x minus 1, and then x is less than or equal to point x plus 1, so that's looping through the 3 tiles in a grid, and then going 3 tiles top to bottom, 1 above, 1 below. Do the same thing with y. And now we'll just say that if x is greater than or equal to 0 and x is less than width and y is greater than or equal to 0 and y is less than height. So that's just keeping it in the bounds. So here we're gonna see how many of the neighbors are walls, and we're gonna store an int that we're gonna return at the end. So it's gonna be 0 to begin. Set wall neighbors plus plus, and if x not equals point x and y not equals point I, or this just makes sure that we don't loop over the currently used tile. We're gonna say that if it's 1, then we're gonna add to wall neighbors. So we have, if it's on the bounds of the region, then we add 1, and if one of its neighbors is a wall, then we add 1, and we're just gonna return that in a new variable, new int called neighboring walls. So now we want that threshold. So we're gonna also put that on a range, and we're just gonna call it threshold, and the range is gonna be from 0 to 8 because that's the amount of walls that can be around. Go back over here and say if neighboring walls is greater than the threshold, then we're gonna set it to 1. So we're going to turn it into a wall. And if it's less, then we're going to delete it if it's already a wall. And if it's at the threshold, we're just going to leave it. That way it gives it more of an organic feel. So we're gonna run through 5 smooth cycles and with a threshold of 4, and we'll get this beautiful caves-like shape. You can see there's like tunnels already made and pieces in between, and very similar to a Terraria like sandbox game. So that's it. Thanks for watching, and before you go, I just want to say that I can't take all the credit for this, and that I got the idea and a lot of how it works greatly from Sebastian Leg. I just shortened it and simplified it for their purposes. So thanks for watching. See you in another video.